Hello everyone. Today we will discuss the topic of stress. Okay. First of all, what is the definition of stress? If I define stress, it is restoring force per unit area. Restoring force per unit area. Okay. Now suppose if I consider a cross section here, so if I draw the FBD of the right half, this external force will remain as it is. Now this entire thing is in equilibrium, right? This entire net force on this entire thing is 0. So net force on this segment should also be 0. So this F will be there, and this is an internal force. So stress at this cross section, it is represented by this sign sigma. Stress at this cross section that we have taken will be F divided by area of this cross section. Right? So this is the stress. Now depending upon certain criteria, there are different types of stress. So if I discuss about types of stress, the first one is longitudinal stress. Now I take the same example. Suppose I want to find out stress at this cross section. So if I analyze the right part of the system, entire thing had net force 0, so the segment will also have net force 0, so this will be F. Now you can see this is the cross-sectional area and this is the restoring force. They are at an angle of 90 degrees. So whenever this is the case, when the cross-sectional area and the restoring force are at 90 degrees from each other, that will be known as longitudinal stress. So longitudinal stress is equal to F perpendicular by A. Remember, I am not referring to area vector. I am saying it is perpendicular to the cross-sectional area, not the area vector. Okay? क्योंकि अगर आप इसका एरिया वेक्टर बनाते तो वो एरिया वेक्टर इसी डायरेक्शन में रहता. Right? So I'm not saying area vector. I'm saying perpendicular to the area. This is the area. When I say area, this is the area. Okay? Types of stress. Types of longitudinal stress. first one is compressive, and the second one is tensile stress. Let us try to understand them. Let us try to understand them. In this situation, the body has been compressed from its natural dimension, and hence when you look at a cross section here, if you draw the FBD, this is the F, this is the internal force. Let me denote it by red. So stress on this cross section will be, and since force and area are perpendicular, so this is longitudinal stress, but this is trying to compress the body. So this is the body has been compressed, so the stress developed here is known as compressive stress, and it has a negative value. It has a negative value. Okay, clear? It has a negative value. When we talk about tensile stress, so if we apply forces like this, if I see any cross section, so if I draw the FBD of that part, this is the internal force. Again, that force is perpendicular to area, so this time again it's longitudinal stress, but this time around this body has been elongated from its natural dimension, so the stress developed is tensile stress. So better say we are talking about the magnitude of stress right now, and when you define compressive stress, it will then have a negative value, and when you define tensile stress, it will then have a positive value. It has a positive value. Okay, so this is about first stress and then longitudinal stress. You can copy this down. Now let's discuss shear stress. In case of shear stress, say we have a fixed end and a force is applied like this. So can I say the dimension will be changed like this? Under the action of the force, this will be displaced like this, right? Now this time this is the cross-sectional area, and this is the force. Now the force is parallel to the area. So can I say shear stress will be right? correct? If I take this case and if I apply forces like this, and if I take a cross section like this, at some angle theta, ask you what is the stress on this cross section. First of all, if I draw the FBD of that part of the right part, it will be like this. Okay, and if this angle is theta, this angle is also going to be theta. So this will be, force will be F cos theta, and this will be F sin theta. तो अगर आप एरिया के रेस्पेक्ट में देखेंगे, if you look at with respect to area, there is one F perpendicular also, there is one F parallel also. So this cross section will have both longitudinal stress as well as shear stress. तो longitudinal stress होगा कौन सा कंपोनेंट इसके परपेंडिकुलर है, sin थीटा, तो F sin थीटा by A, say area of this is A. Say this area is A. Or stress shear will be right. चूंकि वो टेंसाइल स्ट्रेस है इसलिए हम उसको पॉजिटिव लिख रहे हैं. मैग्नीट्यूड तो होता ही, ऐसे भी टेंसाइल है तो पॉजिटिव ही लिख रहे हैं. और वैसे भी ज्यादातर कंडीशंस में हम लोगों को सिर्फ मैग्नीट्यूड से फर्क पड़ता है. ठीक है, तो ये shear स्ट्रेस हो. बल्क स्ट्रेस. नाउ वी विल डिस्कस अबाउट बल्क स्ट्रेस. मान लो एक पार्टिकल है, बॉडी है, बाहर प्रेशर P0, अंदर प्रेशर P0, कोई दिक्कत नहीं चल रहा है. इंटरनल प्रेशर P0, एक्सटर्नल प्रेशर P0, नो इशू. Now suppose for that same body, outside pressure becomes P0 plus dP. So this body will contract and it will feel that effect throughout the volume. इसलिए हम लोग इसको क्या बोलते हैं, bulk stress, bulk, right? If I take a very small area, very small part of area dA, so after a small change in dimension, say equilibrium state is restored. So if I draw the FBD on that dA, there will be a force and there will be a small restoring force as well, because natural dimension has been distorted. So P0 dA plus dFr is equal to P0 plus dP into dA. dFr is dP into dA. dFr by dP, sorry, dFr by dA is dP. Can I say this term is nothing but stress? And since this stress is felt throughout the volume, this is known as bulk stress. I can write that as dP, which is nothing but change in pressure, right? Right? Which is nothing but change in pressure. Right? So bulk stress is equal to excess pressure. This is how we define bulk stress. In the next video then we'll discuss about definition of strain as well as different types of strain. Thank you.